All right, last talk of the day. So, did you enjoy the conference? How great it was. Amazing. I'm so happy to be here again and closing the conference. So, developer experience, right? With Java on Kubernetes. How many of you are using Kubernetes? How many of you like Kubernetes? How many of you like YAML? Nice. All right, so let's get started here. Yes, so I'm Thomas. I work at Systematic. It's a company in Denmark. I'm a software engineer. I'm a cloud architect. I'm really passionate about anything Spring and Java and Cloud Native related. I combined all these passions to write a book. It's called Cloud Native Spring in Action with Spring Boot and Kubernetes. So, before talking about technologies though, I want to ask a question. Let's do this. All right, so why do we build software? Any answer? Like, what? Yeah, so why do we do that? So, someone pays us, I hear, but why? So it all starts because we identify a problem, right? We identify a problem, and we realize, hey, maybe I can solve that problem via software. And then we involve developers, we implement that solution to solve the problem, and finally, what happens is that we deliver value, because we provided a solution, and our end users are happy because we solve their problems, our customers are happy, and our business is happy because we are providing value. So if this is why we build software, the way that we deliver value, the way that we work with software is really important. It all starts with this idea. We find an idea to solve a problem. At some point, we involve a development team to implement that idea. And there it starts what we call the path to production. That, in this case, I'm going to assume it's Kubernetes. And all the activities, everything that happens in this path to production is really critical in order to maximize the value that we want to deliver, both to our users, customers, but also to our business. So today I want to focus on the developer experience with Spring Boot when we work on a Kubernetes environment. And I want to start by defining what is developer experience, because it sounds like a buzzword these days, and I really don't like buzzwords. Actually, there's a developer experience paper from back in 2016, University of Helsinki, and these researchers define developer experience as a means for capturing how developers think and feel about their activities within their working environments. At this point, you could ask, yeah, okay, fair enough, but why do we care? We care because we assume that an improvement of the developer experience has actually positive impacts on characteristics such as sustained team and project performance. So, we care about developer experience because ultimately, if we improve the developer experience, developers are happier, developers are more productive, and we deliver better value faster. That's why I'm talking about developer experience here. And now, I'm going to show different tools today. Kubernetes is a tool, but it's too much easy to consider only tools when we talk about developer experience. The important thing here is that, the important message I like to deliver is that tools are not enough. Of course, we are technologists, so we like our tools. There's a lot of exciting technologies out there. Every day there's something new to try out. But it's important to understand that we also need the right processes in order to support the use of that technologies. Technology alone doesn't solve problems. The way we use it, the processes around the technology, is also a critical part. And ultimately, how the organization is structured, how the people interact with the technology and follow the processes is also a key part of the equation. So overall here we're talking about developer experience as a culture. And I really like this model because you can apply to a lot of different scenarios. Think about microservices. We get the technology to build microservices. So we decide, okay, from tomorrow we're going to do microservices, we're going to break up the monolith, great. But then we don't change our processes. So we keep working with our software the way that we used to, even if we change completely the technology and the architecture. And then eventually the microservice transformation fails, and then, oh yeah, microservices are bad. No, they're just the tools that solve certain problems. So first of all, we need to have those problems if we really want to get the benefits. But then we also need the right processes to work with that specific technology, and we need the right organizational structure supporting those processes and those technologies. So having said that, today I'm going to talk a lot about tools, but please remember that without the right processes and organization, all these tools will not work out. So for today, I have 3 main goals while analyzing how to improve the developer experience when we work with Java and Spring Boot on top of Kubernetes. And the first goal is that I want to achieve a rapid and continuous feedback loop. I don't want to be slowed down while I'm iterating through my code, implementing new features, fixing bugs. I also don't want to get too much cognitive load. I want to focus on a Spring Boot, on how I work with my framework, implementing the business logic that ultimately solves the problem, the original problem that is the reason why we build software. But I don't want to be exposed to too much infrastructure. Otherwise, it's not that much efficient. And overall, the way that we work as developers needs to fit at the higher level as part of this clear and safe path to production. So let's get started and consider the development workflow. So I'm going to work with a simple Spring Boot application, just a reactive web application using the latest Spring Boot version 3.1, and identify what's the baseline. So if we are working just with Spring Boot, let's have a look at what kind of experience we can achieve. So I have the application in here. Let's zoom even more. Very simple. I have a couple of endpoints, root endpoint and a books endpoint. I have a reactive web application. I also want to add the Spring Boot DevTools, because with this dependency in my class path, now I can run the application and initiate a live reload flow. So let's first verify that the application is working. So I send an HTTP request, and it does. And now let's check the books. Working, perfect. Now I can go ahead and update the list. Let's add a new book. For example, the Silmarillion. And then under the hood, the application is reloaded automatically. You can see I get the updated value. Now this is a really great experience, and in Spring Boot 3.1, now we can also use test containers as part of our developer workflow, which makes our experience even better. I'm sure you have seen that a lot between yesterday and today, so I'm not going to showcase that now. If you haven't seen that, if you are not using test containers, I can really recommend that, because it's really great technology and improves a lot our developer experience. Now let me stop my application, because this is the baseline. We have a baseline. Nice developer experience. I generate my project from the Spring initializer. I have this live reload. I can iterate through my code, and I'm happy. But now things need to change. So we're working with Cloud Native application. And by Cloud Native, I mean an architectural style here. As if we compare it with the more traditional stack, before we would work with a runtime environment, the JVM, we would have some kind of middleware, like an application server or a web server. And then on top of that, we would deploy our application packaged as a WAR file or ER file. Now we work with the runtime environment, Java, and then directly we package our application as a self-contained jar. We can run it directly. So if we look at the feedback loop, the iteration loop is one of my goals, right? It was quite slow. We were talking about minutes there to reload my application. And now we can do it in seconds. So the developer experience improved a lot. And if we look at the cognitive load, there was also a quite high cognitive load to deal with the middleware. But now with modern application, we don't have to do that. So that's my baseline. I'm happy. Very fast feedback loop, reduced cognitive load. I basically just need to know about the framework, and I can focus on the business logic, and I'm happy. But I want to go to Kubernetes. So the next step I need to do is containerize my application. And this is where things start getting a bit tricky. Because what happens is that our runtime now will be a container runtime, for example, Docker or Podman. And then on top of that, we package our application as a container image. But now suddenly we have an additional step, and the feedback loop becomes slower. And the cognitive load also becomes a bit higher, because now we need to know how to build this container image. And now the standard way of doing that is writing a Docker file, because writing Docker file is simple. But writing Docker files that are production grade is really not that simple. And also not something that I want to do as a developer, because there's a lot of concerns in terms of security, in terms of performance, and in terms of maintaining the Docker file that I really don't want to deal with as a developer. So I really like working with Cloud Native Buildpacks for that. Cloud Native Buildpacks, probably you heard it already. How many of you are using Buildpacks? No? Nice. How many of you are considering using Buildpacks if you're not doing it now? So Buildpacks is, by itself is a specification that defines how to transform application source code into a container image. And it works across different languages and stacks. So it's a great tool because independently from what kind of application we have in terms of language and framework, we can use Buildpacks and obtain a production-ready container image. Buildpacks comes with a CLI called Pack, but since we're using Spring Boot, we are really lucky because we don't need to install anything else. We can do it directly from the Spring Boot plugin for Maven or Gradle. So if I go to my application from before, I'm using Gradle, so I can say Gradle boot build image, and then my source code is automatically converted to a container image without having to write any Docker file or any additional configuration. So let's give it a second, and we'll get an image. And I can run the image just to verify that it's working. Let's expose it through port 8080. All right. Let's send a request just to verify that everything is good and it's working. So with one command directly from Spring Boot, either Gradle or Maven, I can obtain a container image. And I like that from a developer experience point of view. Let me stop the application and move on. Because now we have a container image, but we are not done yet. Because suddenly now we need to consider Kubernetes. And things get even worse now. Because we started by improving the traditional way of building application. We got Cloud Native application really fast, reduced cognitive load. With containers, we get an additional step. We can mitigate a bit of that with Cloud Native Buildpacks. And now, once again, container image, container runtime, Docker or Podman. But now we got the middleware again. It's back. Kubernetes is our new middleware now. And on top of that, we need to run our application packaged as containers. So suddenly, our feedback loop got as slow as it was at the beginning. And if we look at the cognitive load, it's even worse. So now, if I look at this, then probably you're also wondering why. Why are we even talking about Kubernetes if the situation is so bad? Well, let me tell you two things. First thing is, Kubernetes is a tool, like any other tool, has a specific purpose. It solves certain problems. So I know it's very hyped, everyone is talking about it, but if we don't have those problems that Kubernetes solves, we shouldn't think of using Kubernetes. So I'm assuming here that if we're talking about Kubernetes, it's because it makes sense to use it. And then the second thing I'd like to mention is that we too often end up in this situation because what we do is that we throw Kubernetes at developers. Like here's Kubernetes, now do your work. And now suddenly developers need to deal with a lot of different infrastructural concerns and spend a lot of time there rather than focusing on the specific application. And we would like to avoid that because what we end up doing is start writing all these YAML manifests. So we need a deployment object to identify how to deploy the application, how to scale it. We have a service object to expose the application from within the cluster, and that's not even enough because then I cannot use it from outside the cluster. So I need yet another object. So I have, even if I get a Kubernetes cluster, then I need to configure a lot of things just to deploy my application. And that's not good. That's not how I want to spend my time. I can show you because I need a lot of YAML here. I need a deployment object, I need a service object, I need the ingress object. It's a lot. Now, I can automate the generation of this manifest so I don't have to do it manually, but still the cognitive load is quite high. So let's try to address one of the two problems, because one is the cognitive load, the other one is the iteration loop that is too slow. So I'd like to introduce a tool trying to mitigate some of these problems. And this tool is called Tilt. There are other tools doing similar things. I'm choosing Tilt in order to establish this continuous development workflow on Kubernetes. Now, let's think about how we usually work when, for example, implementing a new feature. We make some code changes, then we build and compile the application, we run the application, and then do some testing and debugging. If something is wrong, we start the loop all over again. This is what is called inner development loop. And when we do this on top of containers and Kubernetes, this loop can become really tedious. So I can use Tilt in order to automate it. So back to the project, I can introduce a Tilt configuration file. And from the CLI, I can say Tilt up. So the experience as a developer feels very familiar, because it's like using, let me do this first. It's like using Tilt up. It's like using Docker compose up. But now what Tilt is doing is executing operations that I would normally do manually. So you can see that I'm calling Gradle boot build image in order to build my container image. I'm deploying the manifest that I have previously written. My application will be exposed through port 8080, so I can work locally on the port 8080 like I would normally do when running locally my application. And then I can even get this live reload that I had at the beginning. This is a feature that is supported by combining the power of Cloud Native Buildpacks, in particular the Paketo implementation, and Tilt. And also, Tilt has a nice graphical user interface. Let's see. Oh, nice. Docker limits. Let's try again. Yeah, so Tilt now, it will start containerizing my application. It will deploy the application using my manifest. And then I can use it and work on it locally. So since I define this, I configure this live reload, then I can continue changing my code in Java like I did at the beginning, and my application will be automatically reloaded. So I solved the problem of the fast iteration loop, but I still haven't solved the problem of the reduced cognitive load. All right. Let's keep that in mind, because things are not over yet. Because we have established this inner development loop in an automated way. We still have the problem of the cognitive load, so let's keep it there. We're going to solve it or see a couple of solutions in a minute. But now let's assume that we have done looping through our code changes, our feature is ready, and we push our code changes. What happens when we are working with Kubernetes is that might be, depending on your process in your organization, that you need to open a pull request and have someone approve it, and perhaps even manually test it. Maybe if it's some feature affecting the GUI, there's going to be some usability testing or something like that. So it would be nice to automate the deployment of a temporary environment where to test our application. And once again, as a developer, I would like not to do that manually or not to be involved that much. So I would like just to open my pull request and then rely on automation to do all the job for me. And in order to do that, I can use a tool like Argo CD. If you have heard about Argo CD, probably you heard about continuous deployment, so for deploying our applications in production. But Argo CD is also a nice feature that can monitor when we open a pull request on our repository, for example on GitHub, and then automatically create these temporary environments where we can test our new feature. And when we are done testing, the pull request is approved, and the temporary environment is destroyed all automatically. So as a developer, I open a pull request, I push it to the application repository, and then this temporary environment is created by Argo CD that will keep it in sync with the changes. So if I make changes to the pull request, then the environment is also kept in sync, so updated automatically, until I have done working on the pull request. So let's have a look at that. I need to switch to a different cluster. I have a repository on GitHub. It's called Music Service. And I have Argo CD running. I just need to expose it. Let's do that. And tilt is stopped. And we get tilt to have internet connection. I don't have internet connection. Okay. Let's go with the Wi-Fi. Yeah. All right, we are back. So I'm exposing Argo CD now to my local host, so we can verify, yes, try again. Localhost 3000. Oh, it's not HTTPS, it's running locally. Oh yeah, of course. Wrong one. 3001. All right, here we are. Yes, it's running locally. Accept the risk. You know, I like challenges. All right, so this is the GUI from Argo. You can see there's no application deployed. Now in music service repository, I'm going to make some changes. Just for the sake of the example, I'll modify the README file, hello Spring.io, and open a pull request in a new branch that I call Spring.io. Let's open the pull request. Yes, create pull request. All right. And then you can see that now the application popped up. So Argo CD find out that, oh, there's a new pull request. So it created a new temporary environment for me. Now it's deploying my application. So for example, I can go to my tester and say, hey, I made some changes. Please, can you test this? After I get all the approvals that I need based on the process in my company, I can go ahead and merge the pull request or close it. In this case, I'm going to close it. Either way, we can see that then the application will be unprovisioned or undeployed and the environment unprovisioned. So you can see it's yellow, and in a few seconds it will disappear. So once again, as a developer, I don't want to deal with too many infrastructural concerns. But that's not enough, because we got the basic experience. Maybe we even understood better why people are yelling at YAML files. And then maybe we realized that, okay, so maybe this Kubernetes thing is not that great. And then we start investigating different tools. And this is a slippery slope, because we can, there are so many tools out there in the cloud native space. For example, one of my favorites is Knative. Knative is an abstraction on top of Kubernetes, and what it does is that it offers a serverless experience on top of it. Kelsey Hightower defined Kubernetes as the electrical grid, and Knative as its light switch. Now, I like this more, because as a developer, if I need to turn on the light, I like operating the light switch. I don't care about the electrical grid, to be honest. So I can use Knative in order to deploy my application. So once I obtain a container image, I can forget about all those Kubernetes resources. And just like I do with Docker, I can simply provide an image to Knative and obtain the application deployed on the cluster. So I can say, I can use the Knative CLI, KN. I can say service create. Yeah, music service, since we were working with that one. And then I can specify the name of the image. Music service. So you can see it's very similar to how we run containers from Docker. We specify the name of the service we want to create, the image, and I don't even need to specify the port number, because I'm using a default port number, 8080. Now Knative will do its magic. So all those resources that Kubernetes need to be configured, Knative will do it for me, and what I get is a URL that I can call, even with HTTPS. So I just get a very nice URL that I call, and I have my application up and running. So this is Knative, which improves the experience a lot. But as I said, this is a slippery slope, because we can't stop here. We're still in trouble when we go from like across the whole path to production. This is only a part of the journey. So I asked yesterday on the application, on the conference application, what does developer experience mean to you? And I got a lot of interesting answers, and I particularly liked a couple of them. One of them said, something a bit different than what today's world is trying to offer. Less tools. I really like this answer. I don't know if the author of this comment is here, then let's chat afterwards. I really like this, and I completely agree. As I said, developer experience is not about tools. We can use tools to improve it, but then the key part there is who is operating those tools and who is using those tools. Capabilities over responsibilities. As a developer, I would like to get all those nice capabilities from all these cloud-native technologies, even from Kubernetes, but I don't want to be responsible for it. Meaning, I don't want to learn all the details and have to work with all those infrastructural aspects just to run my application. I want to focus on my Spring Boot application because I love Spring Boot. I love working with Spring Boot. I want to focus on the business logic. That's what provides value. So it's great to have all these different tools out there, but I don't want them on my plate as a developer. Maybe we can save tilt or something similar. Like, I don't mind running one single command, like tilt up. But then all those tools, I want to push them down to the platform. That's the key part. So developer experience, it's about less tools, and less tools for developers. Because on the other side, we have a group of very skilled people that are experts in Kubernetes, that are experts in building services on top of Kubernetes, that can help us as developers consuming those services. So we get the capabilities, but we don't want the responsibilities because our job is different. We focus on applications, and we have a different team, a platform team, that then provides these services to all the different application teams. And that's why I mentioned several times that developer experience is not just about tools, and we need to consider the organization and the processes. In terms of organization, if you don't have a platform team that takes care of this, then we have the picture from before, where we get a very slow iteration loop, a high cognitive load, affecting all application teams, and that means that instead of delivering more value and faster, we're going to deliver less value and slower. But once we get rid of all these tools, when we say, okay, let's split up responsibilities, we need a way to talk to each other. We need some API, some contract, so that we can consume the services also in a self-service way. So how do we do that? One of the tools that is out there in order to establish this communication between a developer and then the platform is Cartographer, which is what I'd like to talk about now. Because if we consider the path to production, I mentioned developers earlier, but now we're realizing that there are more people involved, right? And we need a way for them to be able to provide their skills and their expertise. We have application operators, we have security experts, platform engineers. We are not alone out there. So we collaborate together towards the end goal that is delivering value, but we have different responsibilities. And as developers, we want to focus on the business logic in particular. Now, back to the question I asked through the conference app, there was another answer that I really liked. He said, let developers be professional and do what they do best. Let them be proud of their work. I really like that answer too. And that's true. As a developer, I want to do what I can do, what I love to do. I want to work with Spring Boot. I want to build applications, solve problems, implement the business logic, and delivering that value. And then there's other groups of professionals, of experts, of skilled people that can work with Kubernetes and use all those tools and provide those capabilities to us as developers. And that's what Cartographer allows to do. Once again, Cartographer is not yet another tool for developers. This is something that the platform team would use in order to establish a path to production. And as developers, what we need to know is what we already know. Think about it. We create an application with Spring Boot, we build all the nice functionality. What information do we have that a platform cannot infer automatically? Well, the name of the application, the Git repository where our application is stored, maybe the branch name, if it's not on the main branch, and maybe some additional metadata like, hey, I'm using Java, I'm using Spring Boot with Gradle, metadata like that. But that's it. And that's what Cartographer allows us to do, is provides this API where we can, which is very developer friendly. It's called the workload API. And as developers, we only need to provide these few pieces of information that we already have. So we have the name of the application, band service. We specify the type of application, like a web application. We have a Git repository where I have my application and the branch. And now I'm using a YAML file, but this could be done through a lot of different ways, through a CLI, through a GUI portal. But the important thing is that as a developer, once I'm done doing all my code changes, I ask the platform to do the rest of the work just by providing this information. This is how I request capabilities from the platform. And then, under the hood, the platform will do its work, but then it's someone else being responsible for that. So, I want to show you an example. Let's stop this one. So, I said that I want to keep tilt again, and that's because I can once again say tilt up, but now tilt, what it's doing is calling that workload API for me. And I have the configuration file in my repository. So this is the only configuration I need in my application repository, where I specify the name of my application, the repository, and you can see my application is in a subpath, so I also specify the specific folder. And then my application, I can follow the work in here. It will be automatically containerized, it will be deployed. Like, I don't even see that. It's using Buildpacks under the hood, but it's not me calling Buildpacks directly. It's provided by the platform. We can have a look. Book service. Yes, so we can see it's still using Knative under the hood, so I get a URL that I can call, and it says, welcome to the jungle. Yes, and let's check the books. Dev. Yes, and we get the books back, also with the change that I've done earlier, adding the Silmarillion. So it seems that nothing changed, but actually, everything that is happening under the hood is out of my control. It's the platform providing that. So using Cartographer, the platform can use any kind of tools, so those tools that I mentioned earlier, in order to implement all the different phases in the path to production and provide these capabilities also to me as a developer in my development workflow, so that I can still maintain this very fast inner development loop, reduce cognitive load, but then it's part of a bigger picture where I have a safe and shared path to production based on Cartographer offered to me by the platform team. And as a developer, I can go back to focusing on my application. And if we go back to the goals, we achieved a rapid and continuous feedback loop, because now after the first tilt up operation, I once again get access to the live reload functionality. But now the whole containerization, configuration, deployment, that is all happening in the platform. It's not me doing that as a developer. So I get reduced cognitive load, because I don't need to know how it works or be responsible for maintaining Kubernetes manifest or doing the deployment. And it's all part of a clear and safe path to production, which I really like. And this is a very nice strategy. It's based on open source tools. For example, it's at the core of Tanzu application platform. It's really nice because it ensures this separation of concerns between what the developer needs to know and work with and what is the platform team's responsibility. So we can improve it a little further because as it is now, once I create my project from the Spring initializer, I still need to provide that initial configuration for tilt and the workload API. So on top of that, and you guessed it, I can add another tool. But once again, it's not me as a developer being responsible for that tool, and that tool is Backstage. So I think I have it on port 3000. So Backstage is a framework to build developer portals. So I can use it for different types of operation. But what I care about here in particular is that I can get access to different templates in order to bootstrap a new project that not only includes all the starter projects from Spring Boot, but it will also include all this basic configuration that allows me to talk with the platform. So if I want to build a reactive Spring Boot application, similar to what I've been working with so far, I can choose the related template. Let's call it demo backstage, add some information. I'm working in the Acme Corp. Next step, I point to my GitHub repo or GitHub account, so that will create a GitHub repository for me, create. And in a few seconds, it will publish the repository to GitHub. Is there. So we can see that contains my basic Spring Boot project. It also contains configuration to talk with Cartographer. So I don't need to write this YAML line. I just check out the project in here. Demo backstage. Developer. So I can do a git clone. I get my project and then say tilt up. And let me ensure yes. So I can say tilt up. Now I have it running on the other project, so it's not running, but that's all I need to do. I bootstrap a project from the GUI, I say tilt up, and then I can work on my project. And if I don't want to check out the code locally, I can even use a remote environment. For example, there's a nice project is called DevPod that has been announced last week. It's pretty convenient because you can create a workspace based on a repository. So, for example, the new repository I just created. And then I can decide to initialize a remote development environment, either locally, for example, on Docker, or on any kind of infrastructure. It's portable, so I can move it around without too much effort. And then I can work with my favorite editor, like IntelliJ and Visual Studio Code. They're both supported out of the box. So for example, I have one project already configured in here. I say open, and then it will open a Visual Studio Code version in the browser, or I can use my local installation of IntelliJ IDEA or Visual Studio Code. And this is build Gradle file. I can work with it. All right. So that was it about developer experience. I have some resources. I'll share the slides if you like to look into it. Also, I maintain a GitHub repository. It's called Awesome Spring that collects a lot of different resources, books, courses, tutorials, events, podcasts. There's YouTube channels. There's a bit of everything. So if you'd like to learn something more about the Spring ecosystem, yeah, you might want to check out this repository. And if you have suggestions for new content, pull requests are greatly appreciated. So having said that, thank you very much. I hope you enjoyed the presentation, and I wish you all a great evening, a great weekend, and I hope to see you all again next year. Thank you.